Welcome back to week 4. Today we're going to continue with topic 4, which is probability and statistics, and we're looking at the subtopic grouping data and reading and interpreting cumulative frequency charts. So last week we took data, an example of discrete data, which was we collected data on the number of grapes on a bunch from a vineyard. And then we took that individual data and we created a bar chart for each one of the entries. So what that looked like was, here's our grapes, and these are the number of grapes that were on a particular bunch, and we collected 43 bunches. Okay, it says 44 because I put 2 titles in here, so it's actually down to 44, but there's 43 values in there. So each one of these values is the number of grapes on a particular bunch that was sampled. Once you highlight that, then you get the bars up here. That says you can make a bar graph out of it. So we just click on that, and then over here you get your bar chart. Now we can get our fives or our statistics on it by hitting the summation key here. Our 5-number summary is the last 5 rows. Then we took this, if I wanted to see a frequency chart with it, a frequency table, I just click frequency table, and there it is. And then we learned to take that and plop it over here into the graphics view so that it is a little bit bigger and easier to see. And so to do that, you clicked on the box here with the arrow in it, copy to graphics view, and you can move things around. What I like to do on this is click zoom to fit. So you notice if I click on the graph grid anywhere, there's a function down here, zoom to fit, and then it gives me a nice clean shot of my bar graph. Okay, now if you had a lot of data points, you'd have a whole bunch of bars, so the graph gets kind of busy looking. And we want to keep it simple so that we can glance at it, get an idea of where we are in terms of what kind of production are we getting out of a typical bunch of grapes in our vineyard. So one way to do that, to reduce the number of bars, is to combine these values into intervals. So for example, I could say I'm going to let one interval start with 1, that's the minimum, and let's say go to 3. And then my next interval would go from 4 to 6. You keep your intervals the same width, and you typically want to get between like 5, 6, 7 intervals. Right? So I got to go from 1 to 21, and I think I set it up so that we get 7 intervals. Now, when you do that on GeoGebra, it does not work out real well, unfortunately, because GeoGebra will turn it into a histogram, and there won't be any gaps in between the data. And since this is discrete data, there should really be gaps in between these bars. So when you do it on GeoGebra, it's not, for discrete data, it's not the best tool. So you'll see I'll set my classes here so that they go from 1 to 3. So I just clicked on set classes manually, and I'm starting with 1 grape to 3, and I'm counting by 2. So if you look at my intervals over here, from 1 to 3, let me make this bigger, copy it to graphics, and it just puts it right over the old one. Now you can get rid of the old one or you can keep it, doesn't matter. It's the new one. Let's see if oops, I just got rid of that. Let's put it back in there. There we go. Okay, zoom to fit. And the problem is that the bins, okay, so it's kind of weird because my bins are set up uh, it should go 1 to 3. It can't go 3 to 5 because you can't have this. This would mean that there's like 3.2 grapes or 3.5 grapes, and that doesn't occur in this list at all. So it's not the best for doing that. So if I wanted to draw a bar chart for this data, it's best really to do it by hand because it's discrete data. Up here, I put some more examples of discrete. And then basically what you do is your frequencies are your y-axis numbers. You take your x-axis, and that's where you're going to put your intervals. You're going to put your frequencies on your y-axis, and then simply draw your rectangles. All right. Where a GeoGebra works a lot is a lot more user-friendly is when we look at continuous data. Right? So there's example of continuous data. It's data that can be measured. Okay, discrete, think of data as counting. All right, so I took 53 students, listed 53 students and their heights, and I put them into our GeoGebra app. So that's what column B is. And then let's get rid of this guy. So I'll hit delete. I'm going to highlight 3. Get my bars up there. Highlight the column. Hit my bars. Okay, and it'll automatically put it into the histogram. Now, in this, from this chart here, my lowest value was set up to be 149.5, and the highest 176, and the intervals were 3 long. Again, you can make those whatever you want. What you have to be sure that you do when you set it up is where do you want the inequality to be, or the equality, I'm sorry, so that you know where, because see, these are the same number. So how do you know which bin it goes into? Well, that's what the equality tells you. 152.5 would actually end up in the second bin because of the inequality with the equals on it. You can choose to put it on this side or on that side. It really doesn't matter. It's a click of a button on GeoGebra. Right? So we go over here. Now I need to adjust. It defaults to a certain bin size, but we can change that by clicking on the gear and clicking on where it says Set Classes Manually. Okay. I thought my recorder was off. Sorry. All right. So set classes manually. And here, right below that, that's the less than or equals to, either on the left or less than or equals on the right. And then we're going to choose count. And up here, I'm going to set my intervals. So starting at 149.5, and then I put 3, enter, and there's my graph. If I want this 5-number statistics, there's my last 5 rows for this set of data. If I want a frequency chart, I just click right below there, frequency table. There's my frequency table for it, all set up. Okay, put this over into graphics. Zoom to fit, and there's your bar chart or your grouped frequency histogram, not a bar chart. And then your grouped frequency table right here. What we're doing today is we're taking these and we're creating cumulative frequency graphs and cumulative frequency curves. All right, so to do that, here's the data from our grapes. So I'm going to uh, create a third column called cumulative frequencies. That's a running total of these frequencies. So my first entry is always the same as whatever the frequency is. And then I take these two cells and I add them up, and my running total is now 8. And I just work my way right down my table. And that column is known as my cumulative frequencies. Now, to create a cumulative frequency graph, we're going to use GeoGebra to do it. And then we'll come, well, let's do it while we're here, just so that we got these other information done. So within our interval here, there's different things that we can identify. For example, one value that we'll be using later on is called the mid-interval value. So this interval could have one grape, it could be made up all of 2 grapes. Everything in here was 2s, everything in here was 3s, or everything in here was 1. We don't know because of the way that we're organizing the data. So what we use to represent this interval is its midpoint. So the mid-interval values for each one of these classes, this would be 2, middle of those 2, 5, the middle of 7 and 9, 8, and so on. 11, 14, 17, and 20. Okay, the interval width, that's how wide our rectangle is. In this case, they were all 2. Okay, then you have what's called the lower interval boundary and the upper interval boundary. So the lower interval boundary are just these numbers here on the left. So 1, and obviously the upper interval boundaries are going to be the values here on the right of the interval. Okay, the modal class, oops, didn't want to do that. Just a moment here, let me put that back up. So the modal class is the interval that has the highest frequency in it. So in our case, our modal class would be the interval of 13 to 15 grapes. Now let's create the cumulative frequency diagram. Now GeoGebra will do it. The way that you would do it if you were doing it by hand is you're going to use the values that are the upper boundary, the upper intervals. So that's these numbers right here. And then you're going to use the cumulative frequencies. Right? These go on your y-axis, and your x-axis is going to contain these, and then you're going to be plotting these points. So you're going to be plotting 3, 2, then 6, 8, then 9, 15, etc. So you're using the upper boundary of the interval and the cumulative frequency. And here's a picture of what it'll end up looking like. So if you look down here, this line here is called the polyfit line. Okay. And there's 3. And then the y value there is 2, etc. All right. So it's to build it. What we're going to do is we're going to draw these rectangles, and then you draw your line, and it's made up by the upper right-hand corner of each one of your rectangles. And then typically you draw it with a nice smooth curve. Okay, not so smooth. But ours is going to look a little linear because we're letting the GeoGebra do it for us. All right. So to do that, okay, let's go back to, let's see, we were on our grapes. Yes, grapes. All right. So we go back, open up grapes, get rid of this guy. Okay, click that. Highlight column A, one variable analysis. Now, it's going to be the histogram, that's fine. But what we're going to do is we'll reset our classes. So we had our classes starting at 1 and going to 3. Now you can do a cumulative frequency graph with discrete data. That is okay. Sorry, it was 2. Okay, and we had the equals on the left. Now I go down to frequency type and I click cumulative. And now I get that's my running total right there. Okay, there's my frequency table for my groups, my intervals. And now to get that curve drawn, I click on frequency polygon. And there's my graph. And copy this over here. Shut that down. Zoom to fit it. And there's our graph. Okay, so this polygon here, this line, the polyline, that is our cumulative frequency curve. Right? And you can, if I just wanted the curve, I can click on those, and then that just leaves me with the curve. Welcome back to week 4. Today we're going to continue with topic 4, which is probability. So one purpose of a cumulative frequency graph is when you have a large set of data, you can use it to estimate your quartiles, your median, etc. So if we look, first of all, let's just take a look at the formulas here. Quartiles, a median just divides the data into 2 sets. Then the quartiles take each one of those sets and divide it into 2 sets. So that's why they're called quartiles. So the first quartile also is known as the 25th percentile. So you got this word percentile, and you have the word quartile. So Q1 and the 25th percentile are the same thing. The 25th percentile stands for 25% of the data is less than that, and 75% of the data is greater than that. So sometimes, like ACT and SAT scores, you're given a percentile score. So if you scored in, let's say, the 90th percentile, that means if there was 100 people in the room, 10 of them scored better than you, 90 of them scored below you. So you're in the upper echelon of the testing. So that's what percentile means. The median is the 50th percentile. Okay, the quarter 3 is the 75th percentile. All right. So once we have the number of data points, we got 43. We can get these values. So our median would be 43 plus 1 divided by 2. That would be the 22nd value in this list. Okay. So if we were just using the chart to do it, I can see that the 22nd value would fall somewhere between, well, I know the 15th value is there, ends at between, no numbers bigger than 9, and then the 22nd is going to be somewhere in this interval where there's 12 numbers. Well, the problem is you don't know how those numbers are distributed in that interval. Are they all 10s? Are there 3 10s and 7 11s and 2 12s? You don't know. Okay, so you can't find that value by just looking at this chart because of the way this is done in intervals. Okay? But we know that the 22nd value, so if we look here on our cumulative frequency graph, okay, this would be 0. The top of my graph, which was at 43, so this is 41, 2, 3. So 43 would represent the 100th percentile. So half of that would be my 50th percentile. Well, half of that was at 22. So if I go to my chart here, my 50th percentile is going to be halfway between these two values. So we said 22. So 1, 2. Now, this is just an estimate because this, first of all, this was made up of straight line segments. It's not a curve. So this is meant to be an estimate, it's not like find the median value. It's use the chart to estimate the median value. So if I go to 22 and I draw a line over to my curve, and then I drop a line straight down from there, that should be a pretty close estimate of what my median should be. Now, when we did it earlier, we found the median was 11. So you can see it's not exact because, again, this curve is drawn by connecting these points here, the upper limit. We'd get a different curve if we connected the lower limit, or we'd get a different curve if we connected the midpoints. So again, all it is just an estimate. And I think the actual on this was 11. Okay, so again, we can get an estimate of where this is. All right, now my next one was the first quartile. Well, that would be taking these 43 items and dividing them into 4 groups. So that would be the 11th term. Okay, so we got our 50. Erase that. Okay, that's our median. Okay, and then our 11th term. Okay, a little bit past 8. So this would be our Q1, or our 25th percentile. And then to get our Q3, well, that's going to be 3 of these, each 11 terms. So that would be 3 times 40 plus 1 divided by 4. So that's the 33rd item. And then you draw yourself a line going down. And I get a little bit more than 14. So this would be Q3. This was the median. This was Q1. And the actual, when we did it, it was 14. Okay, so we're, like I said, these are all estimates. Now the other measurement that that we're going to talk about later on in more depth is called the inner quartile range. So that's the difference between the two quartiles. So that would be, I'm going to take these values. Okay, so if I did it just from these estimates, let's say, all right, let's see, that's 15. So it's a little bit over 14. I'm just an estimate. I'm going to say, oh, I don't know, 14 and a half. Excuse me. And then this, kind of not exactly, just a little over 8. I could probably just say 8 or 8.5. Okay, subtract those two, and that's my inner quartile range. That's where the middle 50% of the data is. Basically, what this is telling you is 50% of the bunches that we picked, the difference in the number of grapes between half of the bunches was around 6. That's what's meant by the inner quartile range. All right, now let's look at it for continuous data. So here are our heights of our students, their frequencies. I added a third column, and now we'll get their cumulative frequency. So this starts off as 3, and then 3 plus 8, okay, 11 plus 6, 17 plus 12, 29 plus 7, etc. Okay, my mid values are going to be halfway between the upper and the lower limits. So since my interval width is 3, to get my mid interval, I'm just adding these two values up and dividing by 2. That's one way. Or if the interval's 3, if I cut 3 in half, that's 1.5. So if I add 1.5 to the lower boundary, I'll get my mid-interval values. So that would be 151, 153 for my next class, 157. I'm sorry, that should be 154, 157, 160, 163, etc. I went ahead and filled in the remainder of the information, and we'll go over it. Everything's color-coded. So our lower interval boundaries, values on the left, upper interval boundaries on the right. your modal class, you look at your frequency column, which one has the most. That would be 158.5 to 161. Then to find the locations of our quartiles, I did the same formulas we did earlier. So the first quartile is at the 13th value. So the 13th value, here's the 10th, 11th, 12th, 13th value. All right, so to estimate this, I got 155.5 is at this line, or 155 is this, 160 is this, so halfway, that would be 175.5. So I'm going to estimate this at somewhere around 156. Right? Our median is at the 26th term. So let's plot that guy out. So 26. That's our 50th percentile. So half the scores above, half the scores below. So estimate my median. There's 160, there's 165. I just kind of eyeballed halfway between. That's 162. So halfway between that would be that's 162.5. So then halfway between that, I'd be guessing this is, I don't know, maybe about 161 roughly. Okay, and then, so that's our 50th percentile, or our median, and then our 75th percentile was located at the 39th value. So I've already got that drawn in. And so this would be Q3. That's 165. That's 170. So halfway, 167.5. So maybe around 166. So now we can get our interquartile range. I'm going to subtract these two. And my interquartile range is 10. Okay, now to do that on GeoGebra, the data is already in there, so it's very quick. And then you can kind of compare your stats to what we estimated here. Okay, so we're back to our chart here. Now, if I want to edit this or change it, guys, right now, it's like you can't move anything. You can't move the windows. So you go up here to these three dots, and you say, open it up in the app. And then you can move around like you did the other day. So there's our heights. Okay, you got a student whose height is 173.5. What percentile is that student in the class or in the group of his classmates? So what you do is you go down to your x-axis, you find 173.5. So I just picked a number, a line that was easy to find. Till I hit my curve, then I'm going to go over. And it's around 46, let's say. Okay, so I want to find the percent that the 46th term is. out of 51 terms. So I'm trying to answer this question. The question becomes, what percent of 51 is 46? So I use this little triangle to do my percent problems. Is 46, of is 51. They're above each other. One's above and below, so that means divide. I get 0.9, so that's about the 90th percentile. So 10% of the students are taller, approximately 90% are shorter. Earlier, we figured out what the mid-interval value was, and later on we'll be using that more. But down here, I just turned it sideways so I could fit it on the paper. But here's the explanation of where we might use that. It says once your raw data has been grouped, it doesn't include the actual values of the data points. Thus, if there's 7 people, a math teacher records the marks obtained by 60 students in the end of the year exam. He displays the data as a cumulative frequency curve. Looks like a logistic curve, actually. Use the cumulative frequency chart to estimate the following. All right, the median. Well, if there's 60 students, our median would be located at, we would do 60 students plus 1 divided by 2. That's the 30.5 student. Well, that doesn't make any sense. So this is going to be midway between the 30th value and 31st value. So if I'm estimating, here's 30, and this is 32, 4, 6, 8. Then I'm going to draw a line over to the graph and then down and use that as my estimate. So I started over here at 31. I drew a line over till I hit my graph and then down, and that comes at about a score of 50%. So half of the students did better than 50%, half of the students did poorer than 50%. Right? The next one is, what is the 25th percentile or quartile 1? So that's going to be 60 plus 1 divided by 4. So we get kind of some funky numbers here. When I do 61 divided by 4, I get the 15.25 number in the list, where again doesn't make any sense. So we would say somewhere between the 15th and 16th value. We're just estimating. So I'm going to go, there's the 20th value. So that's the 18th, 16th. So 15, 16, somewhere around there. And my estimate would be somewhere around 42%. Okay, the third quartile, I'm going to take this, multiply it by 3 of those spaces. Remember, this is position. So this is going to be between the 45th and 46th number, closer to the 46th number. So 42, 4, 6. That's where it touches, and that looks to be about 58%. Okay, the interquartile range then is going to be 58%. Take away the first quartile, 42%, and that gives me 16%. All right, if the pass mark was 50%, how many students passed? Okay, I think I wanted this to be 50 when I typed it out. So if the pass mark was 50, now we're working from the x-axis, and this is going to be really close to the median, but there's 50. Now I'm going to bring that down till it touches the curve, and that tells me roughly 30. So approximately 30 students, because it turned out that the 50th percentile had a test score of 50%. Okay, it just worked out that way. All right, if a teacher wants 90% of the students to pass, what should the pass mark be set at? All right, so I want 90 students to pass, so my percentile is going to be 10%. The 10th percentile. So 10% of 60 is 6. 6, that means 6 students are not going to pass. The rest will. So 54 students will pass. All right, so I'm going to set my box here at 6 students. So 2, 4, 6. Slide it over about 32, 34. Okay, so the pass mark would be 34%. Okay, I'm going to go hop in the water. You guys, and I'll see you next time. Oh, yeah. Ooh.